Now for Lesson 3 video over difference quotients for square roots and rational functions. G of x plus h minus g of x all over h, and that equals, so we're going to put x plus h in for x minus the square root of x all over h. Now typically you multiply and you rationalize the denominator, but when you're applying the difference quotient, you're going to rationalize the numerator. So that means that we multiply the numerator by the conjugate. So that's the square root of x plus h plus the square root of x over the square root of x plus h plus the square root of x. Now, when we do that, we have a minus b times a plus b, and we know that that equals a squared minus b squared. If we have the square root of x plus h squared, that equals x plus h, because the square and the square root cancel each other. Similarly, if we have the square root of x squared, that equals x. So the new difference quotient becomes, the new part comes to be x plus h minus x over h times the square root of x plus h plus the square root of x. So now the x's cancel, so we're left with h over h times the square root of x plus h plus the square root of x. So now this h cancels with this h, and that leaves 1 in the numerator. So our final answer is simply, so this should be g of x plus h minus g of x all over h. And this should be g of x plus h minus g of x all over h. So this equals simply 1 over the square root of x plus h minus the square root of x. And that's what the difference quotient would simplify to. Okay, so now let's go down and try another example. So this is a linear square root. Now on an exam, I will never give you anything harder than a linear square root. So what we have is we have f of x plus h, f of t plus h minus f of t all over h, and that's going to equal the square root of t plus h plus 1 minus the square root of t plus 1 all over h. So this time we're going to multiply by the square root of t plus h plus 1 plus the square root of t plus 1 all over h. All over the square root of t plus h plus 1 plus the square root of t plus 1. All right? So now we have f of t plus h minus f of t will equal t plus h plus 1 minus parentheses t plus 1, because when we square these, the square roots go away, over h times the square root of t plus h plus 1 minus the square root of t plus 1. And that's going to equal, so now we're going to distribute the minus sign here. So we have t plus h plus 1 minus t minus 1 over h times the square root of t plus h plus 1 minus the square root of t plus 1. So the t's and the 1's cancel, and this should be over h. So f of t plus h minus f of t over h will equal h over h times the square root of t plus h plus 1 minus the square root of t plus 1. These h's will cancel and leave a 1 in the numerator. So your final answer will be 1 over the square root of t plus h plus 1. That's a 1. These should be pluses. Plus the square root of t plus 1. All right? And my nose is running. Okay, so now let's go to rational functions. All right? So we're going to have f of t plus h minus f of t all over h. Now when I start this one, I'm going to write it a little differently because I'm going to write it as 1 over h times 1 over t plus h minus 1 over t. And I can do this because remember that if I have 1 over 2 over 1 over h, then that's the same thing as 1 over 2 times, oh wait, hold on. I've got something going on wrong here. Okay, so this would be h over 1 because the h would be in the bottom, right? Because it would be over 1 right here. So this is the same thing as 1 over 2 times 1 over h. So all I'm doing is I'm pulling this 1 over h out in the front to begin with. All right, now I'm going to find an LCD here, which is t times t plus h. And when I do that, I'm going to multiply this side times t plus h over t plus h. And I'm going to multiply this side by t over t. All right, so that gives me 1 over h times t minus parentheses t plus h over t times t plus h. Okay, so the difference quotient, f of t plus h minus f of t all over h equals, now I'm going to distribute t minus h over t times t plus h. And I'm going to go ahead and multiply that h through. So then these cancel. So I have minus h over t times h, just because doesn't matter. Let's just do it the other way. So ht times t plus h. Then this h cancels with this h, and it leaves a negative 1. So what I have is minus 1 over t times t plus h. All right, and that's my final answer. That's it. Okay? So now, let's go here. So this is f of x plus h minus f of x all over h. So again, I'm going to pull that 1 over h out. And so I'm going to have 1 over 4 times x plus h minus 3 minus 1 over 4x minus 3. Okay, so my LCD is going to be 4 times x plus h minus 3 times 4x minus 3. So again, when I find the least common denominator, I'm going to multiply this one by the denominator over here and this one by the denominator over here. So what I'm going to get is I'm going to get the 1 over h, not 1 over 4, 1 over h times 4x minus 3 minus parentheses 4x plus h minus 3 all over my denominator, 4 times x plus h minus 3 times 4x minus 3. Okay? So that leaves me the difference quotient, x plus h minus f of x all over h equals, now I'm just going to write this, I'm going to put my h down here. So I have h times 4 times x plus h minus 3 times 4x minus 3. So this is 4x minus 3 minus 4x minus 4h. And then this sign, so that goes there, and then it goes here. So plus 3. The 4 doesn't go to the 3, just the minus sign. So this goes and cancels with that. This goes and cancels with that. So I'm left with minus 4h over h times 4x plus h minus 3 times 4x minus 3. Now, you do not have to multiply your denominator out. It actually makes it more complicated if you do. So just don't. Now I'm going to cancel the h, and that leaves the minus 4 in the numerator over 4 times x plus h minus 3 times 4x minus 3. And you're done. And that is it. So